Hey, and welcome back to the garage. I just finished up this Moog source for Steve Porcaro. Maybe you've heard of him. And we actually did this a few years ago for him, like just repairing and restoring it. And turned out that it had some modifications done to it a long time ago that he thought were one way, but weren't really that way. Long story short, wasn't doing the thing he needed it to do. And I was like, you know what? Okay, well, we'll redo the mods that you had done previously. We'll do it our way, and we'll also make it work the way you're hoping it does. Unfortunately, these old Moogs don't really do the thing you'd hope they do with the CV and gate inputs and outputs. First of all, the gates are S-Trig, which is kind of a pain to use with modern day CV gate gear. And the CV standard is not 1 volt per octave, even though the manual says it's 1 volt per octave. If you start reading the schematics, you'll see it's actually 1.035, which makes a big difference. And even worse, it doesn't output 1 volt per octave. So unless you're controlling another source, you're really not able to use it to do much. And he wants it to work with this thing that he just had modified by the St. Regis brothers and his Oberheim DSX. So he wants to really interface this stuff because he loves CV Gate over MIDI. And it was up to us, of course, or me, to make it work the way he's hoping it would, and really the way you'd hope it would too, I think. So I'll walk you through some mods. Okay, so bear with me here. So you can see here that we have 2 extra jacks. So we did not add these. The originals would be a TRS jack, and you'd need some type of Y splitter to go in and out CV and gate. But somebody had installed additional jacks so that you could do all those things at the same time, which is cool because then you could use it with like a Oberheim DS2A or something like that, another sequencer that I know Steve loves. So here's what we have. So we have power, of course. So this is, first of all, this is our strip board that we make. You can buy this on our website. It's a basically a prototyping board that I designed because I hate prototyping board because you have to make way too many jumpers to do anything. And this kind of gives you like a row for each IC leg. So here's the IC chip right here. It's a TL082. And that just has like a row going off each leg so you can connect everything a little easier. It's got the spacing here. Perfect for a dip IC. And you have really easy access to negative voltage, positive voltage, and of course ground. So again, I really like it. It's, you know, obviously a product of my own madness. And it works great for stuff like this. It is a little big. I did just recently design a slightly smaller version of this, but those just arrived today and I don't have them in my hand. They're at my shop. So anyway, here we go. On this side, we have the dual CV conversion. So this is actually a circuit that was sent to me by some people, and it was actually drawn by Bob Moog. It is a very basic variable gain amplifier for converting CV standards, mostly for the Micro Moog. So essentially you have the CV coming in from here, going here, and then we're able to trim it with this trimmer to track the source. So you can use a key step or anything that's 1 volt per octave, and it will track the source, which is not 1 volt per octave, slightly more than 1 volt per octave. Similarly, we have the output of the source on this trimmer, so on the second channel of the trimmer, or of the op amp, and that allows us to take the strain standards, I think was more like 1.5 volts per octave, and gain that down or attenuate it to make it 1 volt per octave so that you can control other CV gear with the source. If you so desire. I guess Steve likes that as a controller, so you know, we want to make him happy, of course, so that's what we did. So this will now output 1 volt per octave and accept 1 volt per octave while not changing the actual synthesizer circuitry to be 1 volt per octave, which, believe me, I tried first and failed and just seemed like way too much work this is just a lot easier to implement at the end of the day, especially since we already have the new jacks and everything. So you got some splicing, you know, lots of heat shrink. That's just how mods go. I do have this on sticky pads, so this should be fine, assuming he doesn't leave it in a hot car, which I'm sure he won't. And then here we have 2 additional circuits. So this is a very basic V-Trig to S-Trig circuit. That's, of course, for the gate input. So you can plug a V-Trig into here, or rather here, and that will be converted to S-Trig, which the source wants to trigger its gate. And then we have the opposite of that, which is an S-Trig to V-Trig circuit here. And this is somewhat special in that, first of all, that's usually not the kind of conversion you ever need. It's much less common to see something like this. And we have it running off of somewhat of a high voltage. So we have 15 volts on this gate, and because of the resistance, we'll actually output closer to 10 volts. And 10 volts is great because, first of all, it'll trigger any gear that we need it to trigger, and it will also trigger ARP gear, which Steve also uses, many people use. ARP requires a much higher gate, if usually double 5 volts, so 10 volts plus is great for ARP stuff, and this circuit is running off 15 volts. So yeah, it'll send out a 10 volt gate out of the source so that he can trigger what he'd like. So I'll show you how that looks on the meter, because obviously there's nothing too fun to look at here, and then we'll end this video. Okay, so first I'm going to show you how it works, because that's more fun than the multimeter. Then I'm going to show you on the multimeter. So we have the source working like normal. And then if we plug in the CV, then we can control it from the Arteria. It still works normally. So it's going to hit start here. So what's cool is that it does add the CV. So if I hit a different note, it's going to add that voltage. So you got your transpose here on the source. It'll track nicely because it's expecting that 1 volt per octave. And of course, we can just control it from here if we wanted. Since it does add, it's best to pin that low note so that you can get the concert pitch from your controller as well, because they work together. So now let's move on to the multimeter. All right, so now let's focus on the multimeter. So this is the output of the CV. So if we pin this low note, get about 0 volts, more or less, which is fine. And then if we go up, adds a volt, another volt, and another volt. That very last digit, it is important. It's very, very slightly off. We can trim that out, luckily. But you get that 1 volt per octave, which means we can control other gear just fine. If we move over to the gate, see that we get 0 volts, of course, until boom, 9 volts. So that's enough to trigger pretty much anything, including an ARP 2600 and the like. And that's great. So that'll get us exactly what we need to get this into a sequencer setup. So next is to test this with the MIDI Mini that Steve brought in. And that's this here. This is a Studio Electronics MIDI Mini. It's pretty much literally a mini Moog in a rack case. So he had the St. Regis brothers put CV and gate in this on the back, which is cool. Again, he prefers that over MIDI, which this is, of course, ready with. However, I am now seeing that this has not been calibrated to 1 volt per octave. So we're going to probably tune that. We're obviously not going to do that on video, but we have a nice note up here. That's the source and one oscillator of the MIDI Mini. And see what happens when we go down. So this is very obviously not in tune, which sucks, but we can calibrate it should we please. So of course we did not stop. We had to make this talk to this nicely. So we had to modify this thing too. So MIDI Moogs are not 1 volt per octave. This is a Studio Electronics MIDI Mini, so it has this fun MIDI board over here. And I called the St. Regis boys, who I've known for a long time. And they basically just told me what they might have done, essentially. And I discovered that Greg had modified this by using the modulation pin with a summing resistor. He used a perfect 100K, which would normally be great, but in this case was not. So I basically modified it with a trimmer. I will be adding heat shrink, don't worry. And I was able to basically calibrate that summing node so that the source, of course I hit a wrong note. That's both instruments at the same time, tracking pretty great. I will calibrate it to be perfect. But anyway, that ends the saga of Steve Porcaro's Moog Madness.